Okay, so what I'd like to do is to demonstrate how to do a problem like this. This is an example from your practice problem set from Chem 101. This is question number 9. Now I should note that this problem has a variable in it, and so your number 9 in your assignment may be different than the one I'm demonstrating now, because this right here can change. Right now it wants you to answer the question about substance C, the concentration of C, but the one that you get may be for one of the other chemical compounds A, B, C, or D involved in this reaction. But I still think this demonstration will be very helpful for you in answering questions like this. So it says, for the reaction 3A plus 4B yields 2C plus D, what is the magnitude of the rate of change for the concentration of C when the concentration of D is increasing at 2.7 molar per minute? All right, so I don't know if you remember from class, but what I recommend anytime you have a problem like this, the first thing you should do is to write an expression for the rate of the reaction based on each compound involved, reactant or product. So let's do that first. So the rate of this reaction could be written like this. In terms of A, because A is a reactant, it's going to be negative, and because we have to normalize it, we go 1 over the coefficient, which is 3, times the change in the concentration of A over the change in time. Now if I were to write it in terms of B, so equals, so it's the same rate, but it's in terms of B instead of A, it's also a reactant, so it's negative, 1 over the coefficient, which is 4, times the change in the concentration of B over the change in time, equals, and now we're moving to the product, so these will be positive. These are negative because they're reactants. These will be positive because they are products. So I still need to normalize it for C, so 1 over the coefficient, which is 2, times the change in concentration of C divided by the change in time. And for D, 1 over the coefficient is 1 times the change in concentration of D over the change in time. All right, now that's just the safe way to do it, and the reason why is because then you can see what you know and what you want to know, because you're going to use the term that you know to solve for the term that you don't know. So in this case, I want to know something about C, and I know something about D. Okay, I know that D is increasing at a rate of 2.7 molar per minute. So this is the important part of this long equation right there, because it contains a term for C and a term for D. So let's just extract that out and move it down here. So 1 over 2 times the change in the concentration of C over the change in time equals the change in the concentration of D over the change in time. Now what I want to find is the change in concentration of C. I don't want 1/2 times the change in concentration of C, I just want that right there. So I need to get rid of this 1/2, and of course I can do that by multiplying both sides by 2. Okay, so now I have isolated that term. That's what I'm looking for. So the change in the concentration of C over the change in time equals the change in concentration of D over the change in time. Now that's actually what I'm given. That's 2.7 molar per minute. So I'm going to go ahead and make that substitution. I'm going to substitute that in right there. So 2.7 molar per minute and times 2. So that means my answer is the change in concentration of C with respect to time is equal to 5.4 molar per minute.